All right, let's quickly discuss the law of conservation of energy. All right, especially between gravitational potential energy and kinetic energy. Let's consider an object that is thrown with an initial velocity, u. We don't know what u is, but it's thrown with an initial velocity. As it's going upwards, gravity is pulling it down. So gravity is slowing it down, decelerating it because it's acting against gravity. It gets to a height at which velocity becomes zero. So this height is a maximum height before it now begins its downward descent. So at this maximum height, velocity is zero. So if you put that velocity into the formula for kinetic energy, you must agree that kinetic energy will be zero at the maximum height. But now at this maximum height, it has h. It has its maximum height. So that means that potential energy is maximum because the height is maximum at this stage. So where kinetic energy is, so we have to agree that at maximum height, the potential energy is maximum because h is maximum, has a maximum value. So potential energy is maximum. Kinetic energy is minimum, zero, because there's the velocity at this height is zero. It stops momentarily because of effect of gravity before it now begins to accelerate downwards. Okay, now you must agree that at this bottom here, it has a maximum initial velocity. So if it has a maximum initial velocity, that means half mv squared, the v here become maximum. So that means with an initial maximum velocity, because it's thrown with an initial velocity. So that must be the maximum velocity. So that means kinetic energy will be maximum at the beginning of the journey. And since it's starting at ground level, it has no height. So if h is zero, no height, potential energy is zero. So we can assume that all things being equal, if the potential energy, so if we have the maximum kinetic energy at this point and the minimum kinetic energy at the top here, then halfway we'll have to agree that the potential energy must be equal to the potential energy. So the potential energy must be equal to the kinetic energy at halfway of the journey, when the height h, total height h, is half. Okay, so if you consider that, so we can use the third equation of motion, where v is our velocity at maximum height, 0. The initial velocity, we don't know, take it to be u squared. Then a is now g, okay, for the upward journey, minus g because it's decelerating, and we can use our distance s as h. So this height, okay, so make use the subject formula, you discover that at half height, this is our